All right. So here's what we want to talk about. All right. So we're going to start off with some equations. We're going to go. Let's bring up the font size and make it a little bit bigger. And we're going to go y equals 1 divided by x. And now what we're talking about when we talk about horizontal asymptotes is what happens as x somewhere there's a as x approaches infinity. All right? As x approaches infinity. And what I need you to see is that if I divide 1 by infinity, right? So if I divide, let me go to my calculator. That if I divide 1 by a really, really, really large number, that functionally this is going to get really, 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 really small. Like, and if you think about like how this is a really large number, yes? Compare that to infinity, what is it? It's still really, really small, right? At some point, it'll just get closer and closer and closer to 0. 1 e to the negative 36 means 36 decimal points in front of the 1. So 0.000000. Now, here's my point. Here's my question for you. Does it matter whether this is a 1 or whether this number is 18? Do we agree? It's still going to have a horizontal asymptote of y equals 0. Right? Whether this is 18, whether this is 195, no matter what that number is, however big you make this number, when you compare it to infinity, that number is going to be a really small number. Do we agree? And so what happens is that we're going to get a horizontal asymptote of 1, or of 0, excuse me. We're going to get a horizontal asymptote of 0. Okay? Now, what would you have to do in order for it not to be 0? Well, what about this? What would that be? Do we all agree that would be 1? Right? X divided by x would be 1. Basically, what I'm saying is that, any number divided by itself is 1. But my argument to you is that this is also 1. As x gets really, really, really large, this will approach 1. Now, what I'm saying here, Chloe, is I'm not saying that this is equal to 1. I'm not saying that. I'm saying that this infinity plus 2 divided by infinity plus 7. I'm saying that this will approximate 1. Why? Because at the end of the day, adding 2 to a really, really large number isn't going to change much of anything. Do we agree? I mean, again, if we go back to Bill Gates, I'm pretty sure if you walk up and go, hey, Bill Gates, I think you need $2. Here you go. A, I'm pretty sure he'll take it. B, I'm pretty sure it ain't going to matter any. Right? And my point is, whether this is plus, whether this is minus, all of which is going to be basically the same. It's all basically going to be 1. Does that make sense? And so what happens is, what we end up looking at when we're dealing with horizontal asymptote What I'm interested in is the exponents. The exponents become a critical piece of dealing with how I deal with the horizontal asymptote. Okay? And so, if I have a problem where I say 2x plus 5, 3x minus 7, and I want to know what the horizontal asymptote is, the thing I must look at is the exponents. If these two exponents are the same, and I wish I had a way of I look at these two exponents. If these two exponents are the same, if they're the same, if the largest exponent then it will be y equals whatever these two numbers are. It'll be y equals whatever these two numbers are. Okay? If these exponents are the same, it'll be y equals whatever these two numbers are. Yep. Okay. Now, why is that? If I take 2 times, let's say 100,000 plus 5, and we're going to divide that by 3 times 100,000 minus 7, right? What I'm saying is that will be really, 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 really close. Is everybody see what I'm saying? It'll be really, really close to 2/3. And now, how big is 100,000? 100,000 is actually quite small. I mean, again, in the world of our finances, 100,000 is a whole lot. In the world of infinity, 100,000s are actually really, really small. And so, if you had this problem and you, if you added, a couple more zeros to each one, you'll see that you get even closer and closer and closer to that 0.66667. Does that make sense? So as long as this exponent and this exponent are the same, the horizontal asymptote will be whatever these two front numbers are. And people will ask, what about the 5 and the 7? It doesn't matter, because when x gets really, really large, the 5 isn't going to make any difference. Right? Like 2 times infinity plus 5. The issue is the infinity, not the 5. 3 times infinity minus 7. The issue is the infinity, not the minus 7. And so when we do this, we just simply look to see if these two numbers are the same. If the leading coefficients are the same, it's y equals whatever that number is in front. So with that being said, let's pause this. All right, so To find a horizontal asymptote, again, just to remind you what we're looking for, we're looking at the exponents on the biggest exponent. So in this case, this exponent is a 1. It's not there, but it's implied. If the exponents are the same, we choose the numbers out front. All right? And I don't have any way of coloring those without.
You could highlight. Should be a highlight option.
No, this is EXP, y'all. This EXP is about as user-friendly as a porcupine. All right. If they're the same, we just choose the numbers in front, and everything else washes off. It's y equals 4/3. Yes, sir.
Can I just say that green color makes it hard to see?
Yeah, this is probably a lot of times.
I'm sorry.
You can watch this on your phone, just in different colors. That is annoying.
I'm glad you didn't make it white.
No, I got you.
That's why you picked up that background is the best.
How about that?
Thank you.
But now that's the same color as the damn exponents.
The exponents on this one aren't colored.
This can be blue.
All right.
Or black.
So, for this one, it's going to be y equals 4/3. Y equals 4/3. What will this one be? Y equals 8. Again, we look at the exponents. Hell, dark blue didn't do us any good.
Why would you yellow?
Yellow, I thought was great.
What about dark green though? Yeah, dark green would probably work. There you go.
Is that okay? So we're looking at the exponents. Now, the fact that this one has an x doesn't matter. The fact that this one has an x doesn't matter. It is the biggest exponent, Leslie. Right? So find the biggest exponent, and that's the one you're concerned with. If they're both the same, then you look at the numbers in front. So this one would be y equals 8. Yes.
You said she gave you the vertical asymptote. How did she find that?
She set the bottom equal to 0. That's going to be another discussion we're going to have. Okay. So let's just go over this. If they're the same, okay, it'll be y equals whatever those coefficients are. Does that make sense? Now, what if they're not the same? What if they're not the same? Well, if they're not the same, here's the good news. I could be a preacher if I was just better. Huh?
Did you remember to keep recording?
Yes, I did. Thank you.
So they heard all that stuff about the preacher.
Oh, I could be a preacher. I mean, I don't know enough about the Bible, but if I did know about it, I could. If they're not the same, like this is going to be revolutionary for some people, but hopefully nobody can hear. If they're not the same, they have to be different.
They could be mind blown.
Mind blown, I know, it's crazy. And not only that, but either the top has to be bigger than the bottom, or the bottom has got to be bigger than the top. So let's look at the two cases. So let's look at the two cases. Y equals 5 over x plus 2. In this case, the bottom is bigger than the top. Yes? Y equals x plus 6 x cubed plus 2x plus 6. Y equals 3x plus 4 or 3x to the 5th plus 4, x to the 7th plus 1. All of them, the top is less than the bottom. Do we agree with that? And sometimes I can trick you. All right? And I hate to say I can trick you because people are like, yeah, I know you trick us. But sometimes I trick you by going like this. Y equals cube root x minus 4, 3x plus 2. Right? See, now I've tricked you because to the untrained person, they go like this. Nah, the top is 3, the bottom is 1. No. The exponent for the top is what? 1/3. The exponent on the bottom is? So which one's bigger? The one on the bottom. Does that make sense? See, I can do all kinds of crazy stuff with that. Okay? Yeah, I can. Well, I can try anyway. Remembering that cube root of x, can be written as x to the one-third. So the top piece is functionally x to the 1/3. The bottom piece is x to the first. Right?
Oh, yeah, that's right.
Functionally, the top piece is x to the 1/3. And people are going, what about the minus 4? Remember, we're not worried, in the world of infinity, we're not worried about the minus 4. This top piece is x to the 1/3. The bottom piece is x to the first. Therefore, the degree on bottom is bigger than the degree on top. And anytime the bottom is bigger than the top. Now, for those of my colleagues who are listening to the video because you don't have your own videos,
That's petty, Johnny.
well, that's why they watch mine. I'm using words like bottom and top. Don't kick me out of the club.
Oh, because you're not saying numerator.
Anytime the denominator is bigger than the numerator,
Big word.
so those are big words right there, Cam. And that's why I got a degree, is so I can learn those words. All right? But seriously, if the bottom is bigger than the top, then every time, all you have to say is every time.
Do you ever incorporate negatives to try to confuse people?
Just whenever the bottom bigger to.
If the bottom is bigger than the top,
That is
you mean like a negative exponent? Oh, great question. Then that would go from the bottom to the top, and that would,
Yeah, flip that bad
Yeah, you
boy.
gotta flip
yeah,
it.
then you'd have to flip it. Yeah. Then you like Drake, and you just flip that.
Yeah.
All right. But anytime the bottom is bigger than, so for all of these, for all 4 of those, horizontal asymptote, y equals 0, y equals 0, y equals 0, y equals 0. Does that make sense?
Can you give us an explanation of why it would equal 0 if you make it round?
So, I can. You have 5 cookies. You're dividing them by infinitely many people. How many does each person get?
Microscopic amounts.
How much?
Close to 0.
Damn near 0.
Yeah.
Okay? The bottom piece is going to infinity, and the top piece is functionally not. Because the bottom, and people go like this, well, the top's going to infinity here. Yeah, but the bottom's going at a rate of 3 times. Right? So x cubed is much larger than x. Okay? Does that make sense? X to the 5th x to the 7th is much larger than x to the 5th is. And again, it's not to diminish that x to the 5th isn't pretty big. It is. But compared to x to the 7th, this is still just 1 over x squared. I mean, it's still going to go to 0. Anytime the bottom is bigger than the top, you're dividing by a really large number. You have basically a stationary number being divided by a really, really large number that's going off to infinity, and it's going to be 0. Okay? And it doesn't matter how much bigger it is. Does that make sense? Like, any bit bigger than 0 sends it to 0. To 0. That sounded so screwed up. Any bit on the bottom that is bigger than the top, even if it's bigger just by a little bit, like if the top was x equals, the top is x and the bottom is x to the 1.1, it's bigger on the bottom than it is on top, it'll go to 0. Okay? Any questions on that? Now, what happens if the top is bigger than the bottom? If the top is bigger than the bottom, if that's the case, so that you have like you have this, or you have
When a number's just by itself, that means it has no exponent.
yes. Anytime the top exponent is bigger than the bottom exponent, anytime the top exponent, wrong one. Anytime the top exponent is bigger than the bottom exponent, anytime that happens, you just say it doesn't exist. Now, why is that? Why is it that when the top is bigger than the bottom that there is no horizontal asymptote?
Is it because virtually the bottom is 0, so you're trying to divide it like by 0?
Not quite. So remembering that horizontal asymptote talks about what happens when x gets large. So when we have 1 divided by a really, really large number, right? That goes functionally towards 0. But if we invert that, so that we have a really, really, really large number divided by 1, what happens? And will that number go to any value? No, it just keeps going and it's just getting bigger and bigger and bigger. Does that make sense? So it's not heading towards a single defined number that we have. It's just growing and it's never going to stop, right? And the bottom line is this. It doesn't matter what you divide that by. Whether you divide by 5 or whether you divide by that. It's still, when x gets really large, as x goes to infinity, this is the number on the bottom is basically nothing. It's just going to increase without bound. I mean, it's just, there is no number you can put down there other than, the only thing you can put down there to stop it is another x. Because the x is the only thing that will grow at the same rate that the top is growing. Does that make sense? So, horizontal asymptote. Let's just cover this again. Horizontal asymptote. If they're the same, if the exponents are the same, we use the numbers out front. If the exponent on the bottom is bigger, we use y equals 0. And if the exponent on top is bigger than the bottom, then we use none. Is that fair? So as we move our discussion into vertical asymptotes, you'll find the vertical asymptote by setting the bottom piece equal to 0. So you're setting this bottom piece equal to 0. All right, that's how you'll find the vertical asymptote. Set the bottom piece equal to 0. Okay, so in this case, it would be 3x plus 7 equals 0. And your vertical asymptote would be x equals negative 7/3. Right? In this case, you would set the bottom piece equal to 0. And you would get then you would factor x plus 6, x minus 6. All right, and you would get x equals 6 and x equals negative 6. Any questions on vertical asymptote? All right, real quick, how do I find the y-intercept? Plug in 0 for x. To find the y-intercept, you plug in 0 for x. So the y-intercept in this case would be 3 over negative 36. Y-intercept in this case would be 2/7. Does that make sense? Now, how do you find the x-intercept? How do I find the x-intercept? So if I give you y equals 8x plus 10 over x minus or x plus 4. All right, so let's say that we have this equation. What would the horizontal asymptote be? Let's go to Greg. Greg, what's the horizontal asymptote?
It's 8 by itself, right?
Y equals.
Y equals 8. Yeah, y equals 8. Yeah.
Y equals 8. All right. Now, why do we know it's y equals 8? Because they're the same exponents top and bottom, so you just choose the numbers in front. What's the vertical asymptote? X equals negative 4. Right? X equals negative 4 because we set the bottom piece equal to 0. All right. What's the y-intercept? What is it? 10/4, right? We plug in x is 0. Yes, we can. Right? So to do that, we'll do 8 times 0 plus 10 over 0 plus 4. And we'll get 10/4, which we can reduce to 5/2. Jenna will say 2.5. Okay. Now, how do you find the x-intercept? You find the x-intercept by setting the top equal to 0. Now, that may not make a whole lot of sense to you. Or at the very best for some of you, it'll just seem like something I've just told you to do. Like, well, set the top equal to 0. Why? Because he said so. Why do you set the top equal to 0? If you have a fraction, and I tell you that this is equal to 0, what do I know has to be true? the bottom definitely cannot be 0, right? Like the bottom definitely cannot be 0. If I tell you that I have a fraction where you divide it and you get 0, what must be true, what unequivocally has to be true, is that this has to be 0. And I've had students go, well, no, one of them has to be 0. Not one of them. It's very specific. The top has to be 0. All right? Come on, Cam, hang in there with me. So to find the x-intercept, you set the top piece equal to 0. So in this case, the x-intercept occurs at 8x plus 10 equals 0. 8x equals negative 10. And x is equal to negative 10 over 8, which is negative 5/4. Do we agree? So the x-intercept is negative 5/4. Fair enough?
You don't have to do like the 5/4 and then 0, it's just 5/4. Like how you did for y-intercept. That's the way you write it.
Oh, yeah, you could write it as negative 5/4 is 0.
Hey, Mr. Dryer, make sure you submit that video to YouTube.
All right.
What time?
All right. Any questions on that?